Okay, hi. So I want to do a video on components of vectors. Why do we use them? How do we use them? Like, how do we do the math? And how do we put it all together? And I also wanted to mention, like, instinctively, what do they mean? Okay, so let's start with why we use them. Okay, so first of all, if you go back to those beautiful days of elementary school, you might have had a problem just kind of like this. Okay, 1/2 plus 1/3 is equal to something, and they tell you, do your work, and you try to figure it out. Now, the interesting thing is that mathematically, you can obviously add those things, but you can't add them the way they are. They're based, each measurement is based on a different size of piece. So a half represents, if I have a whole pizza, it means I have one out of two pieces. I cut the whole pizza into halves and I got one of them. Here I have a pizza, I divided it into three pieces and I have one of them. And I want to know, hey, somebody gave me half a pizza and somebody else gave me a third of a pizza to eat. How much pizza did I eat? Now, the problem is that in theory, you should be able to calculate this. I mean, it's math, and those are two numbers. But when we look at these numbers, the way they're written, we can't add them. So you learned, hey, wait a second, I have to change each of these numbers to a different number. Okay, so for example, if I take that number, I can convert it to, using a common denominator, I can convert it 1/2. If I multiply above and below by 3, I end up with 6. And that is 3/6, right? And a half is the same thing as 3/6. And then we said, hey, wait a second, if I can convert 1/3 to a over 6, and I multiply above and below by 2, okay, I end up with that is the same thing as that. And once I have a common denominator and the denominators match, I can add the actual numbers, right? The numerators. So I end up with a 5/6 and I have my answer. Okay. All this to say that you can't add those fractions the way they are. We have to change them into a different way of seeing them so that we can actually compare them and add them. And the same thing happens with vectors, okay? So when we look at two vectors, this is these two vectors are pointing in different directions, and I can't add them. If they were pointing in the same direction, so let's do a different example. If I had a force this way, which was 4 newtons, and a force that way, which is 6 newtons, well, that's pretty easy to see that, hey, if I'm pulling in that direction and you're pulling in that direction, I would win, and I would win by 2 newtons. So if they're in the same direction, I can add them. But if they're at weird angles, I can't. So just like our fractions, we have to change these vectors into a way of seeing them where we can add them. Okay, so that's why we use components. We're using components to convert these vectors so that all the vectors are in a straight line and we can add them in a straight line. That's the purpose. Okay, so there you go. I hope that helps understand why we use it. Next video will be on how do we use it.